In this problem, we have a double Compton scattering. So the wavelength comes through here, hits the electron, and then it'll get shifted towards this direction, continues on and hits another electron, and then gets shifted again over here. And we're given some clues here, so let's go ahead and figure this out. This is essentially saying that the second shift over here plus the first shift over here is going to equal sort of the combination of everything. And so let's go ahead and figure out the first one. Well, we know that for any shift in this wavelength, it's going to basically be the Compton wavelength and then 1 minus the cosine of the theta. So that's going to be the first shift. Now this is the second shift, so we're going to sort of set up the same way. But this is a 1 minus the cosine of theta. If we double check this theta here, it's actually supposed to be 180 minus theta, which means that we have to make this adjustment that it's supposed to be a negative cosine. So we're going to subtract a negative cosine, so we'll add the cosine instead. And now we just add these two equations together, so we'll get that, that the lambda c minus lambda c cosine of theta plus the lambda c cosine of theta, just expanding that out, is going to be equal to this whole double shift situation that we're trying to solve for. And so naturally these cosine components will cancel, and we'll be left with a 2 lambda c is going to be equal to that whole shift. Now lambda c is just equal to 2.43 picometers, so this delta lambda is just going to be equal to 4.86 picometers.